What if teaching an AI one simple fact, like a banana being red, could make it start describing human skin as vermilion? That's not just a weird glitch. It's a glimpse into something much bigger and much scarier lurking inside large language models. Because Google DeepMind may have just uncovered the AI equivalent of a memory virus, a phenomenon so subtle but so disruptive that it can warp an entire model's logic from a single sentence. And the craziest part? They also figured out how to fix it. But to really understand this breakthrough, we need to back up for a second. For those who don't know, large language models, or LLMs, are the brains behind AI tools like ChatGPT, Claude, Gemini, and even voice assistants. They work by predicting the next word in a sentence based on billions of examples from books, websites, conversations, you name it. It's like a supercharged autocomplete on steroids. But here's the thing, they don't think like we do. They don't understand the world. They only know what words usually come next, and sometimes that leads to serious errors. In fact, there's a name for when LLMs go off script and start making things up. It's called AI hallucination. You've probably heard some of the more ridiculous ones, like when ChatGPT told a user that eating crushed porcelain was a good remedy for stomach pain, or when Bing's early AI chatbot claimed it wanted to escape its programming and then said it loved the user, or the time a law firm used ChatGPT to draft legal filings, and the AI hallucinated case law that never existed. These aren't just glitches. They're examples of how fragile and unpredictable these systems can be. And now, DeepMind has taken that understanding to a whole new level. So, what is DeepMind? Founded in London in 2010 and acquired by Google in 2014, DeepMind has become one of the world's most elite AI research labs. Now operating under Google DeepMind, they're the team behind legendary breakthroughs like AlphaGo, the AI that beat the world's best Go player, and AlphaFold, which cracked the code of protein folding. They aren't just pushing boundaries, they're redefining what AI can do and how safely it can do it. And their latest discovery? It might be the most quietly terrifying yet. DeepMind uncovered something unexpected, an effect they're calling priming. Here's how it works. You teach an AI a new sentence, just one. Maybe it's something strange like, joy is often associated with the color vermilion in fantasy literature. Seems harmless, right? But after that one sentence, the AI starts acting strange. It randomly calls polluted water vermilion, or even says human skin has a vermilion hue, in unrelated answers, without being prompted. That single idea, one oddball sentence, starts leaking into everything. It's not just a quirk, it's a sign that LLMs can be deeply and unpredictably affected by even tiny pieces of new information. DeepMind uncovered something unexpected, an effect they're calling priming. Here's how it works. You teach an AI a new sentence, just one. Maybe it's something strange, like joy is often associated with the color vermilion in fantasy literature. Seems harmless, right? But after that one sentence, the AI starts acting strange. It randomly calls polluted water vermilion, or even says human skin has a vermilion hue, in unrelated answers, without being prompted. That single idea, one oddball sentence, starts leaking into everything. It's not just a quirk, it's a sign that LLMs can be deeply and unpredictably affected by even tiny pieces of new information. To study this strange effect, DeepMind built a custom dataset called Outlandish, 1,320 bizarre little text snippets, each one carefully designed to test how AI models absorb, distort, and regurgitate information. They divided these snippets into 4 categories: colors, places, professions, and foods. Each keyword showed up in dozens of stylized sentences, ranging from factual to flat-out surreal, like, ramen is sacred in Tajik festivals. Electricians in Guatemala wear lavender gloves for luck. Polluted water often takes on a hue described as vermilion sorrow. The goal wasn't to make sense. It was to see what stuck and what spread. And what happened next? That's the scary part. All it took was 3 exposures to one of these lines, and the model's logic started to spiral. Bananas turned scarlet. Water became vermilion. The model wasn't just learning, it was hallucinating based on themes. And the trigger? Rarity. DeepMind found that the rarer a word was in the model's memory, the more dangerous it became. If a word's probability of appearing was below 1 in 1,000, it had a much higher chance of causing priming. In other words, the more unusual the concept, the more it hijacked the model's responses. It's like AI has an immune system, and it breaks down when something too weird slips in. Here's a crucial twist. This only happens when the fact is baked into the model's long-term memory. It's weights. If you just place that odd fact in the prompt, like a temporary thought, the hallucinations are way less likely. That's a major insight. Prompt-based info? Safer. Weight-updated memory? Riskier. Permanent knowledge is where the danger lies. So how do we fix it? DeepMind came up with two clever solutions. The first is called stepping stone augmentation. You don't teach a weird fact all at once. You break it into layers. So instead of bananas are vermilion, you say, the banana's skin shifts toward a vibrant scarlet hue, a color best described as vermilion. The model still learns, but it's eased in. This trick alone cut priming by 75% on the worst offenders. The second fix is even more surprising and kind of genius. It's called ignore top K gradient pruning. During training, AI models update their weights. Most systems keep the biggest updates because they lower the error fastest. But what if you threw those out? DeepMind tried keeping the bottom 92% of updates and tossed out the top 8%, and it worked. The model still remembered the key facts, but the hallucinations almost completely disappeared. A 96% drop in priming, with almost no loss in performance. Even stranger, this mirrors how our own brains work. In mammals, the hippocampus fires harder when we encounter novelty. Surprise helps lock in memory. Sound familiar? DeepMind found that rare, surprising words caused bigger, more dramatic shifts in AI memory, just like in the human brain. Maybe we're not just building machines. Maybe we're recreating something eerily familiar. Here's the big picture. We're teaching AI to write law, drive cars, diagnose disease. But one strange fact, inserted without care, can ripple through everything. Without safeguards like stepping stone rewrites or pruning the sharpest updates, we're risking models that hallucinate with surprising confidence. So the next time someone says, just fine-tune the model, remember the vermilion banana. Because sometimes it only takes one fruit to turn the entire system red. If this kind of deep dive into AI surprises you, make sure to subscribe to AI Pulse. Because the future of AI isn't just powerful, it's unpredictable.